Over the past couple of decades, farmers have experienced major climate fluctuations that have directly affected their farms' ability to produce steady and quality produce, resulting in a failure to maintain profit margins. Globally, farmers have experienced massive income decline, with some reporting a 50% drop in net farm income since 2013, and this trend is expected to continue. Efficient production is more important now than ever. However, farmers are unable to take advantage of recent advancements in digital agriculture techniques to assist with this challenge. While techniques such as robotics, sensors, and electronic identification are beginning to become more accessible to small scale farmers, one technique that has seen massive development recently, but still remains out of reach for most, is yield estimation. Techniques of estimation have been used since the 1940s for a range of purposes, from assessing food security in developing countries to the calculation of insurance rates used by crop yield insurance companies. Notably, these techniques have also been used by farmers to assist with financial decision making. However, they often involve a tedious manual process with lots of effort required by the farmer only to produce a yield prediction that lacks accuracy. These techniques can only be done weeks before harvest, leaving little time for the farmer to make important farm management decisions.
Recently, advancements in crop modeling and remote sensing yield estimation techniques have led to the possibility of increasing the accuracy of estimations while also being able to predict yield earlier, potentially even before the crop has been planted. The benefits of accurately predicting yield earlier is that yield is crucial to delivery estimates, harvesting and storage requirements, as well as cash flow budgeting. Some recent crop modeling techniques have even started to incorporate weather data into their prediction algorithms, allowing early identification of the effects of climate change. If implemented, these advancements will have a direct impact on the farmer's ability to make informed decisions regarding their finances, affecting their overall survival. Unfortunately, many of these new yield prediction techniques do not take the form of commercially available products that can be utilized without a strong technical understanding of how the model works. A current cutting edge software package, Apsim, has been developed to help with the running of crop estimation models. However, it still requires an understanding of computer programming to implement, which many small scale farmers do not have, limiting the overall accessibility of the technology.
Our solution will bridge the gap between farmers and yield prediction models by developing one easy to use interface. This interface will allow farmers to utilize the latest and greatest models for yield predictions. The overarching system can be broken up into three main components: data input, data process, and result display.
Farmers will provide the system with as much or as little data as they have readily available for the crop they wish to predict. This data will be referred to as active data. The model will then retrieve data not required by the farmer, such as weather forecasts. This will be referred to as passive data and is retrieved by the system automatically. This method of data collection minimizes the amount of effort required by the farmers. Using the passive and active data provided, the system will select the estimation model with the highest accuracy. This is because model availability and accuracy is dependent on the active data. For example, satellite imagery might not be available for farmers to utilize based on the region, resulting in another model being selected. After this model is selected, the yield estimate is calculated and the data is then ready for display. The yield estimation information display will aim to display yield estimation data in a way that farmers will be able to understand. It will have a simple overview of expected results in conjunction with a more complex analysis of the crop and variables that affected its growth. All this information will be easily exported to allow for a variety of stakeholders to view the information and easily extrapolate the data to help make decisions to benefit the farm. In short, climate volatility is affecting the efficiency of traditional yield estimation techniques, and combined with farmers' inability to utilize current technologies, has led to a general increase in inefficiency of yield cultivation. Our solution addresses the lack of accessibility of current cutting edge models by simplifying the estimation process into a clear and effective website that all types of farmers are able to take advantage of to better their farm survival.